Alright guys, today we're going to look at finding the greatest common factor and factoring each expression. So the greatest common factor, the way we find it is we find the greatest common factor of all of the numerical coefficients or the numbers that are in front, and then we find the greatest common factor of all the variables. And the product of those two pieces becomes our overall greatest common factor. In the first example, I have two terms I'm looking at. I have 8x squared and I have 4. I know that they're separate terms because they're separated by an addition sign. So I'm looking for the greatest common factor between 8x squared and 4. Really, I know that x squared is not going to have a greatest common factor because there's no variable attached to that 4. So what I'm looking at are the numerical coefficients, which are 8 and 4, and I'm trying to figure out what the greatest common factor would be. I know that I can divide 8 by 4, and I would get 2. And I can also divide 4 by 4, and I would get 1. So I can divide both of these numbers by 4. Let's try 8. I can divide 8 by 8, and I would get 1. If I divide 4 by 8, that's going to leave me with a fraction. So I know that I won't be able to use 8 as my greatest common factor. So my greatest common factor here is going to be 4. That means I can divide 8x squared and 4 by 4. So if I take out 4, which is the GCF, 8x squared divided by 4 is going to be 2x squared. The x squared stays because I can't divide it by 4, so I just bring it down. Then I have this positive 4. I'm dividing 4 by itself, so that becomes a positive 1. I know that this is factored correctly because if I wrote down what I had, and I went back and I distributed that 4 back inside those parentheses, this would be 8x squared plus 4. Okay, so this means that this is the factored version, or the factored form of my expression. In example 2, I have 6x cubed minus 3x squared. 6 and 3, again, we're trying to find the GCF. 6 and 3 can both be divided by 3. X cubed and x squared can both be divided by x squared. So my greatest common factor is 3x squared, meaning I can divide 6x cubed and 3x squared by my GCF. So I'm going to take 3x squared from both of these pieces, meaning I'm dividing. So 6x cubed divided by 3x squared. Remember, when you're dividing like bases, you subtract the exponents. So this becomes 6 divided by 3 is 2. X cubed divided by x squared is just x. And then 3x squared divided by itself is going to be 1. Remember, I have the subtraction sign in between that I have to bring down. In example 3, my numbers are 5 and 2, and I can't find a factor or a number that goes into both of those coefficients. So there won't be a common factor for my coefficients. My variables are y and z to the 4th. Again, there's nothing that they have in common, nothing that goes into both, so I don't have a GCF here. This would be a non-factorable expression You would also call this a prime expression, meaning it cannot be broken down. In example 4, my GCF for the numbers, I have 17 and 34. I can divide 17 by itself. I can also divide 34 by 17. If I tried to divide 17 by 34, I would have a fraction. So I know that 17 is going to be what I can divide both of those numbers by, meaning that's my GCF. For the variables, I have x cubed and x to the fourth. I can divide both of those variables by x cubed because it's the smaller exponent. I also have y squared written down twice, so I know obviously I can take that out as a common factor, meaning my overall greatest common factor is 17x cubed y squared. And if I take that out of this expression, 17x cubed y squared divided by itself is going to be 1. 34x to the fourth y squared, 34 divided by 17 is 2. X to the fourth divided by x squared is x, and y squared divided by itself is 1, which I'm not going to write down there. Just to clean this up a bit, my factored version of this problem is 17x cubed y squared times 1 minus 2x. Remember, you can always check your solutions by redistributing and making sure that you end up with where you started. Which is the case. On our last example, I have negative 3x cubed y plus 2x squared y minus 5xy. GCF, first we look at the numbers. I have negative 3, 2, and negative 5. Those numbers have nothing in common. Looking at the variables, I have x cubed, x squared, and x. I'm always going to choose the variable that has the smallest exponent, which in this case would just be x. Then I have y, y, and y. Well, obviously it's going to be y. So my greatest common factor is xy. So I'm going to divide all three of these terms. Remember, terms are separated by addition and subtraction. So those are three terms. I'm dividing all three of those terms by xy. The numbers, the coefficients, negative 3, 2, and 5 are not going to change because I didn't pull a number out. I only took out variables. X cubed divided by itself is x squared. Y divided by itself is 1. 2 didn't go anywhere. X squared divided by x is x. Y divided by itself is 1. Negative 5 didn't go anywhere. X divided by itself is 1. Y divided by itself is 1. So this is going to be the factored form of that expression. And again, just to clean it up a little bit, I'm going to rewrite it below. All right, that is factoring expressions using the greatest common factor.